In the second part, we're going to look at what defines a logarithmic function. Here we have our logarithmic function f of x is equal to log base a of x. Now, there's a couple of rules. First of all, x has to be greater than 0. So this x here, which we call the argument of the log, has to be a positive number greater than 0. And also, a also has to be greater than 0, but then a is also not equal to 1. And this is similar to our definition of an exponential function, where we had these same rules apply. So now we have some properties of logarithms that we can look at. And the first one is that if we have log base a of a, that is equal to 0. And we have log base a of 1 is equal to 0. Now, the way we want to think about a logarithm is we want to say what power of. When we look at logarithms, we can say, okay, we have a log base 2 of 4. The way that you want to read these is you want to say, what power of 2 gives me 4? And the answer is the second power. If I looked at log base 2 of 8 and I asked myself, what power of 2 gives me 8? That would be the third power, because we know that 2 to the third power is equal to 8. And you can do all logarithms like this as long as they're nicely built. For example, if I had log base 5 of 25, I can ask what power of 5 gives me 25? And that would be the second power. You can also go backwards with it too. What power of 25 gives me 5? Now this is a little bit weird, but remember that the square root of 25 is equal to 5. And we can also use 5 to the 1, or 25 to the 1/2 power is another way of writing the square root of 25, which is equal to 5. So what power of 25 gives me 5? That's equal to 1/2. You can do negative numbers as well. What power of 2, what power of 4 gives me 2? That's going to be the square root. Or you can do, as I said, a negative number. What power of 2 gives me 1/4? This would be negative 2, because 2 to the negative 2 is equal to 1/4. Now, normally in my class, I would spend a lot of time working with these logarithms and getting comfortable with them. But because we don't have all that kind of time, there's actually a way that you can just solve all of these anyway using a calculator. And it's called using the change of base formula. And the change of base formula says that if you have a log to any base of any number, then you can change that into log base t of b over log base t of a, where t is any base. Now for us, what we're going to do is we're going to make that t equal either 10 or e. And the reason why we're going to do that is because those are the numbers that your calculator can do. This log here that we have, this is log base 10, and this ln here is the natural log of log base e. So let me show you an example. And let's say I had log base 5 of 32. Now I have no idea what this is, but I can change this into the log base 10 of 32 over the log base 10 of 5. Now, log base 10 is known as the common log. And we just write log of 32 would be represent log base 10 of 32, but we just write log base 32. If we have a log base e, that's known as the natural log. And that's a logarithm using Euler's constant. But this would represent a log base e. We could use 32. All right, there we go. So the reason why we use log and ln, which is the natural log, I know it's confusing, but I always write ln in cursive, and I write the common log is just log. So now if we come back to this example here, where I have log base 5 of 32, I can separate that into the common log of 32 over the common log of 5. And then I'm just going to take my calculator and I'm going to do the log of 32 divided by the log of 5. And I'm going to get 2.15. Now it doesn't matter if I use the common log or if I use the natural log. If I use the natural log, which is this ln button down here, I can do the natural log of 32 divided by the natural log of 5. And you want to make sure you use this parenthesis right here after the first number, otherwise it gets wonky. You're going to get exactly the same number. And so that's how you can do logarithms of any numbers.